Today we will be looking at the 2003 UK Chemistry Olympiad questions. Comparing to other past year questions, the 2003 questions are actually very easy. So I would suggest anyone who's preparing for the UK Chemistry Olympiad to try this questions first and get a taste of how are the questions like and what does it test you on. So we will start with question 1 first. The question is about a self-heating can of coffee, which uses a system of a very dilute solution of sodium or potassium hydroxide and calcium oxide, maybe creating a exothermic reaction with water to generate the energy needed to heat up the can. So we will start with A. I will also categorize all the sub-questions in terms of whether it's an AS or A2 level content. So for A, it is an AS inorganic chemistry content. So A is relatively easy. You just have to remember the reaction of period 3 oxides with water. So in the case of calcium oxide, it's calcium oxide plus water, which will give you calcium hydroxide. Always check if the equation is balanced or not, and in this case it's already balanced, so we will move on to B. B is also an AS level content. It tests you on some concepts relating to equilibrium, and let's start by deducing how would the pH of the solution affect the rate of reaction in the heating can. So what is heating up the can is the reaction in A. And if I have an acidic condition in the can, my acids will react with some of the hydroxides generated here, and this will push the equilibrium towards the exothermic side, which is in the direction of the forward reaction. And so we will expect the rate of reaction to be greatest in an acidic condition, followed by in a neutral condition, and finally a basic condition. In basic conditions, you will have a lot of a high concentration of OH minus ions, which will push the equilibrium towards the reactants, which is in the endothermic direction. Okay, now on to C. C is also an AS level content. It involves you drawing some Hess's law diagram and to calculate the standard molar enthalpy change using the standard enthalpies of formations of the reactants and products. So for the reaction in A, the standard enthalpy change of the reactants would be negative 635 minus 286 kilojoules per mole, and for calcium hydroxide it's negative 1003 kilojoules per mole. So we are interested in finding the enthalpy change of reaction of this particular reaction. So the enthalpy change of reaction is basically the enthalpy change of formation of the products minus the enthalpy changes of formation of the reactants. So I will have negative 1003 minus bracket minus 635 minus 286, which gives me negative 82 kilojoules per mole. I'm sure many people will be familiar with the Hess's law at this point, so I will not explain it in further detail. And D, we are trying to find the heat capacity of the, we are trying to calculate the energy needed to warm this amount of coffee by 40 degrees Celsius. And the heat capacity is assumed to be same as water, which is 4.18 joule K. Okay. This is also an AS level content, which is in the thermodynamics part, and in thermodynamics we calculate energy change by the equation Q equals to mc delta T, where Q is the energy change, M is the mass of a substance that you are heating, and C is the specific heat capacity of the substance that you are using, and delta T is the temperature change. So in this case it will be 2010 centimeter cube of coffee, which is assumed to be the same as of water. So 1 millimeter will be 1 gram, so I will have 2010 grams multiplied by 4.18, then multiplied by the temperature change, which is 40 degrees Celsius. So I will have 35112 joules. Note that the units of the enthalpy change and the energy release here is not the same. So in E, we are going to calculate the minimum mass of calcium oxide needed in the can to function. What does it mean by function is to warm the coffee by the conditions stated in D. So E, this is a AS stoichiometric level question, and we will have to calculate the number of moles required to release this amount of energy. So what does the standard enthalpy change of the reaction here means? It means that for every moles of calcium oxide, the reaction will release negative 82 kilojoules per mole of energy. So taking that into consideration, the number of moles of calcium oxide here will be 35112 divided by 82,000, which gives me 0.428 moles. But the question is asking for the minimum mass, not the number of moles, so we have to convert it to mass using the formula M equals to mR times N. So we will also have to find the molecular mass of calcium oxide, which is equal to, you have calcium here, 40.08 plus 16 for oxygen. So we will have 56.08 gram per mole. So for 0.428 moles of calcium oxide, the mass would be 0.428 times 56.08. Which is 24 grams. And that's the end of the question.